मला निघायला लागल.
Hello, am I audible?
Yes, ma'am.
Yes.
Oh, okay. Is this visible?
Yes.
Yes, what was the statement I have given to you as a homework? Have you solved the example? Yes. Can anyone please tell me the answer? Am I audible clearly? Yes. Please reply.
Now
Am I
audible
audible
clearly?
clearly?
Yes, ma'am.
Yes.
Yes. So is there any problem with the example? I have given you one problem statement as homework. Have you solved it? Quickly, can anyone please tell me the indexes for 1? First number is 25. 3, 21, 13, 1, 2, 7, 12, 4 and 8. What is the bucket size? 0, 1, 2, 3. Okay. So 25, it will go at 5. Then 3 at 3, 21 at 1, then 13 at, yes, 13. Tell me the index for 13. Fast.
4.
4, correct. Then for 1,
2.
yes, for 1,
2.
2. Okay. Then for 2,
6.
6. But here with replacement is asked, no? The linear probing technique with replacement. So we need to now at index 2, 1 is there, but for key 1, 2 is not the perfect index. So we need to remove this 1 and shift this 1 to the next empty location, that is 6. And then at index 2, place 2. Okay? Okay. Next number is 7. So index 7. Is this visible?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes or no?
Yes,
Okay.
ma'am.
Someone is saying I'm not audible. Am I audible clearly?
Yes, ma'am.
Okay. Now next number is 12. Again 12. Okay. Now what will be the index for 12? It is 2. But since 2 is not empty, we need to find out the next empty position. And already 2 has occupied the number 2, which is the correct index of that key. So we need to find out the next empty position. So what is the next empty position? It is 8. Isn't it? So this 12. After 12, 4 is there. So when should I place 4? Index 4 is not occupied actually. At index 4, we have written 13. But for 13, 4 is not the proper index. So we have to replace this 13 by 4 and move this 13 at the next location. Next empty location is 9. So I'm going to place 13 at index 9. Okay. So after 4, what is the next location? It is 8. Okay. So for 8 also, I have placed 12 at index 8. Isn't it? But again, for 12, the actual index is 2. 8 is not the actual index of 12. But for key 8, 8 is the actual index. So we need to replace this 12 by 8 and search the next empty
Zero.
position for 12. So what is the next empty position? 12 at index 0. So starting from 0 to 9, your keys are 12, 21, 2, 3, 4, 25, 1, 7, 8 and 13. Got this? Is this simple? Yes? Yes or no?
Yes, ma'am.
Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So, shall I take the next problem statement? Now we are going to see chaining techniques. Chaining with replacement and chaining without replacement. So, let's solve the problems of chaining with and without replacement. Okay? Linear probing technique with replacement, without replacement. I think these concepts are clear now. Isn't it? So, should I take the next problem statement?
Ma'am,
Yes.
what about number of comparisons in it?
Number of comparisons. Yes, tell me the number of comparisons. You can find out the number of comparisons, no? For 1, yes. Now, according to your table here, 1 is placed at 21. So, number of comparison for 1 is 1 only. Okay. After that, next number is 25. 25 is also placed at its actual proper index. So, again, for number of comparisons for 25 is, sorry, not 1. Actually, first number is 25 itself. So, for 25, your comparison, number of comparison is 1. After that, number is 3. 3 is also placed at actual location. So, number of comparison for 3 is 1. After that, 21 is there. So, for 21, index is 1. It is kept at index 1 itself. So, number of comparisons is 1 for 21. Next is 13. Yes. Now, where 13 is placed? Yes, where 13 is placed? 9, na? So, how many number of comparisons are there? Tell me.
Ma'am,
Is
7.
it 7? Yes, correct. It's 7. So, plus 7. Next number is, after 13, next number is 1. So, 1, actual index of 1 is 1, but it is placed at location 6. So, number of comparisons are? Yes,
Ma'am, 6.
correct. Next one is 2. 2 is placed at 2 itself. Okay, so number of comparison 1. Next number is 7. 7 is placed at 7 index. So, number of comparison is 1. Then 12. Now, what is the actual index for 12? It is 2, but we have placed 12 at index 0. So, how many comparisons required?
3, ma'am.
Yes, 3 or
9.
9?
9.
Correct, it is 9.
9.
Yes. Now, after that, 4. 4 is placed at 4, that is 1. 8, 1. So, total number of comparisons you can find out. Okay.
29.
Yes. 20.
9.
Is it 29? Yes.
Yes, ma'am.
Now, is it clear now? Yes?
Yes, ma'am.
Okay. So let's take the next problem statement. Let me give you the screenshot. Just wait a minute. Is this visible? Please
Yes,
write
ma'am.
down the statement. Please write down the statement. Finished? Hello? Yes. Do you remember we have already studied this technique? Do you remember the concept of without replacement, chaining without replacement? Can you try to solve this example? Just try it.
Yes,
Try
ma'am.
to construct the hash table and tell me the answers. नेट नाही आहे का? Yes. Finished? Okay. Now, for the chaining method, you need to construct table like 0, 1, 2, 3, 4. These are the indexes. Okay. This is chain. Is this visible?
Not visible, ma'am.
Not visible? Hello?
Now it
Now
is
it is
visible.
visible, ma'am.
Is it visible? I have
Yes,
drawn
ma'am.
the table.
Yes, ma'am.
Yes, ma'am.
Okay. Okay. So let's start solving this problem. First, we will apply without replacement technique. Okay, chaining without replacement. So take the first number, that is 11. You can place 11 at index 1. Here. And okay, after 11, next number is 33. You can place it at 3. After that, 20, you can place at index 0. Then 8, 9, then 98. Now for 98, the slot. Reply me. What is the next empty slot?
2.
Is it true? 2?
Yes, ma'am.
Yes, yes, ma'am.
Yes. So should I place 98 at index 2?
Yes, ma'am.
Yes, ma'am.
Yes. And what is the chain? Where should I place the chain value? It is at index
8.
8. Got this? Do you remember this? We have studied this technique. When we started learning this unit, hashing, the first point we have studied is chaining with replacement and without replacement. We are just now solving the problems. Got it? Yes? Now the next is, after 98, it is 44. So 44 I am going to place at 4. Yes. After that 68. Now again for 68, we need to place 68 at 8, but position 8 is not empty. It is already occupied. Okay. So where can I place 68 in the hash table? Can anyone please tell me the index?
5.
Next empty index?
5.
5. Correct.
5.
So 68. Yes, exactly. And where should I place the value of chain? And what will be the value? The value of chain is 5, but at which index in the
2.
chain table I am supposed to place 5?
At 2.
2.
2, correct, exactly. Very good. Now after that, next number is 66. Where should I place 66? At index 6 itself, because it is empty. Then 22. Where should I place 22?
7.
7, correct. So I'm going to place 7 at index 22. And where should I place the chain value?
At 7.
At 7. Value
5.
of chain is 7, but at which index?
5.
Correct.
5.
It is 5. And all the remaining, yes, all the remaining fields in the chain table, I need to write -1. It indicates these values are empty. -1. Got this? So this is the table or hash table for chaining without replacement. Got it? Yes? Is it clear?
Yes, ma'am.
Yes.
Okay. Next is chaining with replacement. Okay. Now let's see chaining with replacement. Again, 0, 1. This is key. This is chain. Now 11. 11 at 1. 11 at 1. 33 at 3. Then 20 at 0. Then 88 at 8 and 79 at 9. Okay. Next is 98. So 98, index is 8, but 8 is not empty. It is occupied by 88 and that deserves that place because 88 has a proper index 8. So we cannot replace 88 by 98. We need to search according to the linear probing. We need to search the next empty position to insert 98. So next empty position to insert 98 is, yes,
2.
2.
2. So I'm going to place here 98. And what is the key value here? 2. Is this correct? Is it correct?
Yes, ma'am.
Yes, ma'am.
Yes. Yes. Now the next is, next number is after 98, it is 44. So you can directly place 44 at 4. After 44, 68. Now again 68, we need to search the next empty position because it will also, according to the hash function, the index for 68 is also 8. Now next empty position is again 5. So here 68. And where should I place the chain value? 5 at index 2. Correct? Is it correct?
Yes, ma'am.
Yes, ma'am.
Yes. Okay. Now next is 66. Where should I place 66? At 6? Yes. Now next is 22. Yes, 22. Where should I place 22?
2.
At index 2.
At index 2, isn't it?
Yes, ma'am.
But at index 2, we have already placed 98. But for 98, 2 is not the proper index. So we need to remove this 98. I'm going to remove this 98, place 22 here. Now this chain value is also, we need to delete that also. And what is the next empty position? That is 7.
7.
I'm going to shift 98 from index 2 to index 7 here, and the value of key value or chain value of 98, now it is 5. That is the index of 68. Okay. And can I remove this one? So according to the new replacements, here the key values, all other key values are -1. Now here you need to change the key chain value of this 88 also. Okay, what is the key value here? The value of index of 98. Index of 98 is 7. So this is your chaining with replacement technique. This is the hash table for given numbers or for inserting given keys into the hash table using the chaining with replacement technique. Got this?
Yes, ma'am.
Yes? Is it correct?
Yes, ma'am.
Okay. Everyone, is there any issue? If you have any doubt, please ask me. Yes. Clear? Is this clear? Now let's take the last example, then we'll finish the next theoretical part. Yes, last example. Let me take the screenshot. Is this clear? Two 501. Then resolve collisions using technique. I will give 5 minutes to solve this example. Solve the example and tell me the answers. How many keys are there total? How many keys are there?
11.
11. And table size is 15.
15.
So you can take the mod function as key mod 15. Consider the mod function as key mod 15. Like suppose your first number is 35, 35 mod 15. What is the value of index?
5.
5. So place 35 at index 5. Accordingly complete your table and tell me the indexes. Finished? Yes? Can anyone tell me the answers? Tell me the index for 36.
6.
Index for 6. For 25.
10.
10. For 47.
2.
Correct. For 2501.
11.
Correct. Next is 129.
9.
9.
Right. Then 65.
12.
For 65.
5, ma'am.
7, ma'am.
5. 5
Seven.
is not empty. So next empty position for 65.
7.
7. Correct. After that, after 65, 29.
14.
14. Correct. Yes. After 29, 16.
1.
1.
Correct. For 14,
14.
it is 14, but 14 is already occupied. So next empty location
3.
after 14 is
3.
0, no?
Yes, ma'am.
0
0.
is
Yeah,
also
yeah,
empty.
0.
Yes. So you can place 14 at 0. After that, 99.
12.
12.
Yes.
Exactly.
12.
So finished? Yes? Okay. So these are the examples for open addressing, close addressing, linear probing on chaining with replacement, without replacement. Okay? I think now all the concepts are clear. Isn't it? Is there any issue? Is there any problem? If you have any doubt about these points, because we have already seen all the theoretical concepts as well as we have solved the problems of each and every concept. Now I think all the doubts are clear. So should I take the next concept?
Yes, ma'am.
How many students are there in the meet? Actually, there is some internet problem from my side. I am not able to see, or I am
75.
not able to connect from my laptop. How many participants are there?
75.
75. That means only the half students are present today. So what should we do? Should I start the next concept or should we continue in the next lecture?
Start the new concept.
Next lecture?
New concept.
Or should I start it? Huh?
Ma'am, start it. Almost तो यही strength रहती है mostly.
75?
70. Yes, ma'am. 70, 80 strength ही रहती है almost.
Okay. Okay then. Just wait a minute. Yes. Now the next concept is extensible hashing. Okay, give the heading extensible hashing. Now, if you want to handle large amount of data, then you can use the extensible hashing technique. Okay, this technique is normally used to handle the large amount of data. The data to be placed in the hash table is actually you can extract, or you can insert the data in terms of the bits. For example, if you want to insert 4, you need to insert the binary format of 4, that is 100. If you want to insert 1, you need to insert 001. If you want to insert 5, you can insert 101 in terms of bits. Okay, so this is the concept of extensible hashing. Now it is actually same as the binary tree. It is the concept of B tree only. So in extensible hashing, it referring the size of the directory and the elements are to be placed in the buckets. Okay, and the levels are given for each and every placement of the keys. So for example, suppose this is 0, this is 1. So this is the extensible hashing hash table in which some values are placed, and you can specify the level 1. Okay, so this is the directory. This is called as the directory. This 1 in the bracket indicates the level. And data to be placed in the bucket, you can place in this container. Here, data to be placed in the bucket. So the bucket can hold the data of its, you can say it is a global depth. So if the data in the bucket is more than the global depth, then split the bucket and double the directory. You can change the size of the directory. You can move to the next level. You can increase the depth. Okay. For example, let's see the insertion operation, how we are going to insert the numbers in the extensible hash table. Okay, here insertion operation. So consider one example for understanding this insertion operation. Suppose if you have to insert numbers 1, 4, 5, 7, 8 and 10. Okay, so assume each page can hold only 2 data entries. That is, the depth of the table is 2. Okay, so for each and every table or each and every container, you can place only 2 values. Okay, so start with the first container, or you can say 0. This is the directory, 0 directory. So at the 0 directory, at level 0, I am going to place number 1. So for number 1, what should I write here? Binary format, that is 001. Okay. Next is 4. So what is the binary format? 4, it is
100.
So I have placed 2 numbers in 0 directory, 0th directory at level 0. Okay. So we will examine last bit of the data and insert the data in the bucket. Okay, now to insert 5, the bucket is full. We cannot insert 5 in 0 directory because you can place only 2 values at one directory or at one bucket. Now since your bucket is full, that is bucket size is 2, hence you can now double your directory. Now how to double the directory? Just make one more directory, index 1, now level 1. Okay, now the next number I need to place is, yes, what is the number?
5.
5. So where should I place 5 now?
I did next one.
Here, 1, 0,
0,
1. But what is the logic behind placing the elements or placing the keys in the bucket is, we will examine the last bit of the data and insert the data accordingly in the bucket. Okay. Now if you see these numbers 1, 4, 5, here 0, 0, 1, 1, 0, 0, 1, 0, 1. So last bit of these two numbers 1 and 5 is 1. So I am going to place 101 and 1001 and 101 in one bucket at index 1. So I am going to remove this 11001 and I am going to place it at index 1 at directory 1. Okay. Clear till now? Yes, is it clear?
Yes, ma'am.
Okay. Now in the step 2, what is the next number? Now your next number is 7. Okay. So to insert 7, I am going to insert 1, 1, 1. Okay. But as depth is full now. Okay. And we cannot insert 7 here. So then double the directory. Again, you need to increase the directory size and split the bucket. Okay. Now how to split the bucket now? Now till now we have used only 0 index, 1 index. But we have to again increase the size of the bucket and you have to double our directory. For that I am going to consider it the directory name as 00, 01, 10 and 11. So this is 0, 1, 2 and 3. Got this? Got this? How I am going to double the directory? First I have created a directory 0. Then I have double directory by adding 1. Now again I need to double my directory or I need to increase the directory size. So I am going to take the 2 bits. Okay. Now consider the last 2 bits again. So this is my 00 first directory 100. This is already placed. Now this is your level 1 as we are increasing the depth. Now at 01 we have already placed 2 numbers, that is 001 and 101. Keep it as it is. This is your level 2. Now 10. And next is 11. Now what is the number I should have to insert is 111. Now if you check the last bit, it is 1. Now consider last 2 bits, that is 11. So you need to place 111 at 11. So 111. Okay. Now the next number is after 7, it is 8. So value of 8 in the binary format is 1000. Where should I place this? At index at level 1 in directory 00. Got this? Is this correct? Yes. Now after that, next number is 10. So what is the binary format of 10?
1010.
1010. Where should I place this?
At index 10.
At index 10. Exactly. So I am going to place 10, that is 1010 at index here 1010. Okay. So yes. Okay. So this is the basic idea of how to place the data or how to insert the data using the extensible hashing technique. Got this? Okay. Now next is, now this is the insertion. Now how you can delete the operation? Now suppose if you want to delete 10, then simply make the bucket of 10 empty. That is, bucket of 10 means this bucket. You need to just empty this bucket. So I am going to delete this. So this is the delete operation. You can delete the number 10. I have deleted this number 10. Okay. Now next, suppose if you want to delete 7. Okay. How you will delete 7? 7 is kept at bucket 1 1. Okay. So here I'm going to delete this. Now when you delete this, your label, this is empty, this is empty. This is empty, this is empty. Okay. Now this directory 0 1, which is at level 2, that will decrease the level as 1 because we have deleted the subsequent levels. Got this? Got it? Now again you can remove the entry from first directory, that is 0 0 also. Suppose if you want to delete 8. So 8 is there in the first directory, that is 0 0 index. So you can simply delete this number, no need to change the level because there are again two numbers in 0 1 position, so you cannot decrease the level. Got this? How to insert and how to delete the elements in the extensible hashing? Yes? Yes or no?
Yes, ma'am.
Okay. Now the next point is applications. Applications of hashing. So in compiler, do you know the concept of compilers? In compilers, to keep the track of declared variables, you can use the hashing technique. For online spelling checking, the hashing function can be used. Hashing helps in game playing programs to store the moves you are going to make to play the game, or for browser programs while catching the web pages. Hashing is used in browsing technique also. Okay. So there are many more applications of hashing. You need to just note down, or you need to just identify those applications. So this is your again homework. Just try to find out as many as applications of hashing technique. Note it down. Okay.
Yes, ma'am.
Got it? Is there any problem? Okay. Now the next and last point of the first unit is skip list. Okay. So that we will cover in the next lecture. Your first unit is almost about to end. We'll take only one more lecture to complete your first unit. So, is anyone has the attendance link? Can anyone please share that link? Can I stop my presentation?
Yes, sure.
Okay. Can anyone have the link for the attendance? I will give you the code. I don't have the link now. Yes, this is the attendance link and code is yes, this is the code. Code is given in the chat box. Give your attendance and you can leave. Should I end the meeting now?
Ma'am, code is not there.
Which code? Attendance link?
Attendance
Attendance
code.
code is not in the chat
Yes, ma'am.
box.
CO0215.
Okay, ma'am.
CO 02 15. Okay. So shall we stop today? Link is there in the chat box, Aditya.
Yes, ma'am.